Hello students, welcome to Saurabh Sir's classes. So in today's video we will be solving a few questions from mathematical statistics. So the question goes like this. So the first question is, let the x1, x2 and x3, xn be independent binomial variate common parameter small p equals to capital P, x1 equals to 1. So now let Sj equals to x1 plus x2 plus xj for j belongs to 1 to n. Now we have to show that Sj equals to r and Sn equals to small s does not depend on probability and takes the form of hypergeometric probability where j belongs to 1 to n and r and s belongs to 0 to n. So I'll be giving you 1 minute so that you can go through this question once. So read the question carefully, then we'll proceed further with the solution. So I hope you guys have gone through it. I have given you enough time. So now I'll come to the answer. For this, what we have to do is, here Sn tends to binomial n comma p. So this hint, first we need to remember this hint. So now from here we'll write probability of Sj equals to small r intersections Sn equals to small s. So which will equals to j comma small r probability p to the power r and q to the power j minus r. So this is n minus j and s minus r, which is multiplied by p to the power s minus r, q to the power n minus j minus s plus r. So we can write this way. Now from here we can write probability Sj equals to small r given Sn equals to small s equals to probability Sj equals to small r intersection Sn equals to small s given probability Sn equals to small s. Now this can also be written as small j. So small j r given n minus j s minus r divided by ns, which is 1, say it belongs to j belongs to 1 to n, where 0 belongs to r, s belongs to n. So a result which is independent of p. So this result is independent of p. So first go through the questions, that is we have to take the form hypergeometric probability. So here in this case, as you can see, it is free independent of p, so we can say this is the right answer. So if you have any query or question, first I'll ask you to go through the solution once for a couple of seconds, then we'll proceed further with the questions, other questions. So I hope you guys have gone through this once. So the result is independent of p. Now still, if you have got any queries, or like we haven't got into the nitty-gritties of this sum, so if you want to know more about this kind of sum, I'll be giving you my number, which is 9836793076. You can simply WhatsApp me on this number, or you can also go to our website, which is www.saurabhsirsclasses.com. So now we'll go to the other sum. So in the next question, so in this question it is given an urn contains W white balls and B black balls. Balls are drawn one at a time from the urn without replacement. Now find the probability distribution of the number capital X of draws needed to obtain the kth black ball. Find also the factorial moments of expectation capital X bracket small r. So first I'll give you couple of seconds, or say 1 minute, to go through the question, read it like couple of times, so that it will be clear to you what they are actually asking for. So I hope you guys have gone through the question. So now I'll be solving this question. So this question goes like this. So first we have to remember that probability capital X equals to small x equals to b small b k minus 1 and w b x minus k, it will be x, sorry, so it will be w. So if you further solve this question, it will be w by x minus k divided by b plus w x minus 1, we can write it this way, multiplied by b minus k plus 1 divided by b plus w minus x plus 1, which is equals to x minus 1 and k minus 1, b plus w minus x and b minus k divided by b plus w by b. So we have found the fractional moments of expectation of AXR is given by, first we have found this, now we will find the expectation of XR is given by KR b plus w plus 1 to the power r divided by b plus 1 to the power small r. So we have solved the question. We have found the expectation of x to the power r. So which is this. So I'll be expecting you to go through it once for 1 minute so that it will be clear to you before we go to the next question. So I hope you have gone through it. So if you still have any query or doubt, I'll be giving you my number, which is 9836793076. You can simply WhatsApp me on this number, or you can also go to our website, which is www.saurabhsirsclasses.com. There you will find a lot of other videos like this. You will also get to see a lot of other materials which are needed for mathematical statistical questions. Now we'll go to the next question. So the next question goes like this. If n dice, each of which has 6 faces marked 1 to 6 are thrown, find the probability of getting a sum small s on them. So we'll simply go to this, we'll solve this. Now we have to write x1 tends to binomial n comma p and x2 tends to binomial n plus n2 comma p. So this is the answer for this question. So now we are done with this answer. So now we'll go to the next question. So if you want to know more about all this, how do we get this, how do we solve it, I'll be giving you my number, which is 9836793076. You can simply go to this number, or you can simply WhatsApp me on this number regarding your doubts and suggestions. So now we'll go to the next question. So we'll go through, one second. Now if n dice, each of which has 6 faces marked 1 to 6 are thrown, find the probability of getting a sum small s on them. Now how do we solve it? For this first, we have given the hint, which is the exhaustive number of ways in which n dice can fill is 6 to the power n. Now, since the total number of permutation in which 6 numbers that is 1, 2, 6 taken small n at a time can add to small s is the coefficient of x to the power small x in the multinomial expansion of x plus x square plus dot 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 plus x to the power 6 to the power n. The required number of favorable cases for getting a sum s on a dice is the coefficient of x to the power s in the expansion of x plus x square plus dot 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 x to the power 6 to the power small n. So now we'll take another page to solve it. So the required probability is equals to 1 by 6 to the power n, which is the coefficient of x to the power s in x plus x square plus dot 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 plus x to the power 6 to the power n bracket. So now what we have to do is we are simply have to write now identically we have x plus x square plus dot 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 plus x to the power 6 equals to x into 1 plus x plus dot 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 plus x to the power 5, which is equals to x into 1 minus x to the power 6 divided by 1 minus x. Now, and by binomial expansion, we can write x to the power n into 1 minus x to the power 6 to the power n equals to summation k equals to 0 to n minus 1 to the power k into n ck x to the power n plus 6k and 1 minus x to the power minus n equals to summation r equals to 0 to infinity minus ncr minus x to the power r equals to 0 to infinity n plus r minus 1 cr into x to the power r, which is equals to summation r equals to 0 to infinity n plus r minus 1 c n minus 1 into x to the power r. So we can write it this way. From here, hence we can write 1 minus x to the power minus n is equals to summation r equals to 0 to infinity minus ncr into x minus x to the power r equals to summation r equals to 0 to infinity n plus r minus 1 cr x to the power r, which is also equals to summation r equals to 0 to infinity n plus r minus 1 c n minus 1 x to the power r. Now from here, hence we can write x into 1 minus x to the power 6 divided by 1 minus x to the power 6, or say n, is equals to summation k equals to 0 to n and r equals to 0 to infinity minus 1 to the power k point n c k n plus r minus 1 c n minus 1 multiplied with x to the power n plus 6k plus r. So far we have done this. Now to find the coefficient of x to the power s, we put n plus 6k plus r equals to s, that is n plus r equals to s minus 6k. Thus, the coefficient of x to the power s in x plus x square plus dot 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 plus x to the power 6 to the power n is equals to summation k equals to 0 to s minus n by 6 to minus 1 to the power k n c k to s minus 6k minus 1 c n minus 1. So the summation being extended over the integral values of k not exceeding s minus n by 6. So in today's video we solved two questions. Now we'll go to the question again. So this was the first question, which was n dice, each of which has 6 faces marked 1 to 6 are thrown. So we have to find the probability of getting a S on them. We have found it. If you simply can go through it once again. So it started this way, the exhaustive number of ways this way. So we have solved it. Now still, if you have queries regarding this, if you want to know more about this kind of question, I will be giving you my number, which is 9836793076. You can simply WhatsApp me on this number so that to clarify your doubts, or you can also go to our website, which is www.shauravsirsclasses.com. There you will find a lot of other videos like this, and you will get study material for various exams related to mathematical statistics. So thank you for watching this video. If you have still any query or doubt, I have given you my number. You can simply WhatsApp me on this number. So thank you for watching this video. Have a nice day ahead.